Okay, so we're going to just practice some back and forth. You're going to have to pardon the construction. But we're going to practice back and forth going from an augmented matrix into back into a system of equations. So if I have this set up, 4, 12, 14. So remember, this is your X column, this is your Y column, and this is your answers column. And that vertical bar simply means that that's where the equal sign goes. So this actually means that you have a 3x. Positive 9 means you got a positive 9y, and that's going to equal 4. And then across the bottom, this is your X column, Y column equals your answers. So that's actually is a shortcut way of writing 4x plus 12y is 14. Okay? So that's just another method of trying. So that's going to work. So let's go backwards a little bit. Give me a second. Okay, so we're just going to go back here. So if I kind of overloaded you on the first one. So I have a 4, 2, 12, 8. And my instructions are to take a negative 3 times row 1 and add it to row 2. Okay, so the first thing I want you to do is write it in mathematical notation. So negative 3 times row 1 and then add it to row 2. Okay, so what did we learn in the intro video? What that means is negative 3 times row 1 plus row 2. Plus row 2 is written last. So that's what's going to change on my paper. On my paper, row 1 will not change. So row 1 simply looks like a 4, 2. Okay, so this is what you're supposed to do in your head. I'm going to take a negative 3 times row 1. So a negative 3 times 4 and a negative 3 times 2. So a negative 3 times 4 gives me a negative 12. Negative 3 times 2 is a negative 6. So I've taken that negative 3 times row 1. Now I'm supposed to add it to row 2 and put my answer in row 2. So row 2 says 12 and 8. So add those together, put your answer in row 2. Add those together, put your answer in row 2. And that's how you're going to translate that stuff. So just remember, if you've got addition, subtraction, whatever's written last is what's going to change on your paper. So theoretically, you're supposed to move from here to here. So what I would have done is said negative 3 times 4 is negative 12. Plus 12 is 0. Negative 3 times 2 is negative 6. Plus 8 is 2. So on paper, row 1 does not change, but on paper, row 2 does change. Okay? So let's try a couple more. We are going to go ahead and use Gauss-Jordan elimination to solve this thing. So my system is x plus y must be 5, but x minus y must be 0. Okay, so I'm going to translate this from a system of equations. So remember, I've got an x column, a y column equals my answers. Okay, so now that I've got that organized, now I can translate that into a matrix. So I've got 1x, 1y, and that's going to equal 5. I've got 1x, negative 1y's, and that's going to equal 0. So I've taken it from a system of equations notation and I've changed it into a matrix notation. So what's our strategy? This first upper left spot needs to be a 1. Well, that's great because it already is. Okay, so we saved a step. The second step is once this is a 1, we're going to make this a 0. Okay, so how do I make that into a 0? 0 is going to use adding and subtracting. So if this is, I'm trying to change that 1 into a 0. If this is a negative 1, then a negative 1 plus 1 will 0 that out. So in my head, I'm going to take negative 1 times row 1 and add it to row 2. Okay, negative 1 times row 1 plus row 2. So what does that look like? On paper, which you're not supposed to do, I'm going to change all the signs on row 1. Okay, so here's what I got. I took negative 1 times the entire top row, and now I'm going to add it to row 2. So these two together give me a 0. These two together give me a negative 2. These two together give me a negative 5. But remember, this is all shortcuts. That's why we're supposed to be doing it in our head. So the top row is not changing. Okay? Top row does not change. So now I've got my 1 and my 0. This needs to be a 1. How do we generate a 1? Either using multiplication or division. So because we're using shortcuts, I'm just going to say take a negative half of row 2. So a negative half of row 2, what is negative 2 times negative 1/2? It's 1. So I'm not even talking about row 1 on this, so I'm just going to rewrite him. So he's a 1, 1, 5. And then what is a negative half of 0? It's 0. What is a negative half of negative 2? It's 1. What is a negative half of negative 5? It is 5 halves. Okay? So I've got a 1, 0, 1. Now this needs to be a 0. So how do I generate zeros? I'm going to see how this column interacts. If this was a negative 1, negative 1 plus 1 is 0. Okay? So on my paper, row 1 is going to change. So plus row 1. So what do I need to do to row 2? I need to change the sign of row 2, because this just needs to be a negative 1, and everything else will just kind of fall into place. So row 2 is not going to change on paper. Okay, so let's just look at it from the side. If I do need to do it, I'm just going to change all my signs on row 2. So I've got a 1, 1, 5, and this is going to be a 0, a negative 1, and a negative 5 halves. So I changed my signs on row 2. Now add them together and put your answer in row 1. So 0 and 1 is 1. Negative 1 and 1 is 0. And 5 minus 2.5 is 2.5, which is 5 halves. Okay? So now we have solved that system of equations. So let's go through and do a couple more. And I need to show you what happens and what it looks like when it goes to an infinite number of solutions and when it goes to no solutions. Okay, so here we go. We have 5x minus 2y is a 2. And then 10x minus 4y is a 1. So that's my system of equations. So the first thing I'm going to do is make sure it's organized. So I've got x's, y's equals numbers. And now I need to decide, my first strategy is turn that 5 into a 1, and we're going to do that using division. So this is a 10, a negative 4, and a 1. So all I'm going to do is change the top row. I'm going to divide the top row by 5, which is the same thing as multiplying by 1/5. So my bottom row is not changing. Okay? So now I got a fifth of row 1. Divide everything on the top by 5. So 5 divided by 5 is 1. Negative 2 divided by 5 is negative 2/5. 2 divided by 5 is 2/5. Okay? So I've got my 1. What's my next spot? I need to get this to be a 0. So how do I make zeros? I need to use multiplication and addition. So if this, ignore everything else. If this was a negative 10, I could add it to positive 10 and zero this out. So I'm going to multiply the top row by negative 10 and add it to row 2. So on paper, row 1 is not changing. So he's a negative 2/5, and he's a positive 2/5. Okay, so I'm going to take negative 10 times row 1. I need another piece of scratch paper. Give me a second. Okay. So on paper, I'm going to take negative 10 times the top row. And again, you're supposed to be doing this in your head. So negative 10 times 1 is negative 10. Negative 10 times negative 2/5 is positive 20/5, which is positive 4. And then negative 10 times positive 2/5 is a negative 20/5, which is a negative 4. And then my bottom row is what I'm adding and subtracting with. So I'm going to add these, add these, add these. Okay? So what do I have? Negative 10 plus 10 is 0. And my answer goes in row 2. 4 and negative 4 is 0. And my answer goes in row 2. Negative 4 and 1 is negative 3. And my answer goes in row 2. So something horrible just happened because I just zeroed out this side, which means I have no x's and I have no y's. So what this is saying is that 0 equals 3. Well, 0 can't equal 3. So this is an impossible situation. If this is impossible, so go back through and think what that means. What that means is that there is not a single xy coordinate that satisfies both equations. It's impossible. So these are parallel lines. That's what you just figured out. These are parallel lines, which means your solution is the empty set. There's nothing that's going to work. There is absolutely nothing that's going to work. Okay, so let's try a different one. So what I have is a 2x plus a 5y equals a negative 7. And then I have a negative 6x minus 15y is 21. So that's my system. And now I'm going to convert. So I've got x's, y's equals numbers. So it's organized. Now I just have to convert it to a matrix. So I've got a 2, a 5, a negative 7, a negative 6, a negative 15, and a 21. So what's my first step? My first step is to make this a 1. So how do I change a 2 into 1? I divide by 2, which means I'm going to write half of row 1. So row 2 is not changing. Row 2 is not changing. So what's half of 2? It's 1. What's half of 5? It's 5 halves. Okay, what's half of negative 7? Negative 7 halves. So I got my 1. Now I need to make this a 0. So ignore everything else. If this was a positive 6 minus 6 will give me 0. So I'm going to multiply my top row by 6. And add it to row 2. So on paper, my top row is not changing. On paper, my top row is not changing. Okay, but on paper, my bottom row is changing. So just so that you can get used to it, take 6 times the top row. So 6 times 1 is 6. 6 times 5 halves is going to be 30 halves, which is 15. 6 times negative 7 halves is going to be a negative 21. And then my bottom row is a negative 6, negative 15, 21. So add those together, put your answer in row 2. So 6 and negative 6 is 0. 15 and negative 15 is 0. Negative 21 and 21 is 0. All right, so new situation. On this one, I've lost control. Hang on, where'd it go? I don't know where it went. All right, on the last one, what happened was I went to 0. I don't know where it went. It went to zeros on one side and some other number on the other. Well, this time I got zeros across the way. So here's your question. Does 0 equal 0? Yes, it does. Which means these two are actually the same line. Okay, so it looks like two different lines. Now here's a sneaky trick. If you notice, if I multiply the top row by -3, 2 times -3 is -6. 5 times -3 is -15. -7 times -3 is 21. So these are the same line, and I could have figured that out to start with, which means there are infinitely many solutions. So what we're going to do is we're going to list the infinite number of solutions, but we're going to hold y arbitrary. So what that means is when I look at this as a big coordinate, y is going to stay y. Okay, y is going to stay y. Since these are effectively the same line, I'm going to grab one of them and solve it for x. So I'm going to grab the top one. Why? Because it looks prettier. All right. So all I'm going to do is get x by itself. So I'm going to have an x equals scenario. So I'm going to find out what x looks like, and I already know what y looks like because I'm deciding to hold y arbitrary, which I'll explain that in a second too. So I'm going to subtract 5y from both sides. So I've got 2x. Okay. And now I'm going to divide everything by 2. So I get x is the same thing as -5/2 y minus 7/2. So instead of writing an x here, I'm going to write this. So this gives me a -5/2 y minus 7/2. Okay, so what does that mean? That means that this is my x coordinate, because x equals that. This is my y coordinate, and there's an infinite number of them. So when I say that y is arbitrary, that means y can be anything I want it to be. So if I choose 0, okay, that means this thing times 0 minus 7/2, that means this is -7/2 and this is 0. Okay, if I choose 1, then -5/2 times 1 minus 7/2 is -6, 1. Okay, so y is arbitrary, meaning I can choose for y to be what I want it to be. So if you're told to make x arbitrary, then x is going to be an x, and then grab one of those two and solve for y. So it says y equals, and then you'll have stuff with x's over here. So it would look like x comma a bunch of x stuff. So the last one I'm going to go ahead and walk through with you. So I'm going to talk it out, and I'm going to let you finish it. So I've got a building contractor hires 6 day laborers, okay, and 1 concrete finisher. And then his payroll is $10.30. If he hires 1 day laborer and 5 concrete finishers, then his daily cost is $9.45. Find the daily wage for each type of worker, which means I just set it up for you. You've got this column, which is already organized with days. You've got this column, which is already organized with concrete finishers, and I need it to equal this daily rate. So when you convert that into a system, it will be 6x plus 1y is going to equal 1030. And then I've got 1x plus 5y's is going to equal 945. And just to give you a quick little hint on that, these are both equations, which means I can write them in the opposite order. So I can put the bottom one on top, and I can put the top one on the bottom, and look what magic happens. I got a 1, 5, 945. I got a 6, 1, 10, 30. So you've already got your 1 going. So make that a 0. That's already a 1, which is going to change, but it's okay. You can make it back to a 1, and then make that a 0. All right, so that is it for Chapter 5, and then we're going to learn about stuff for next week, and then you're ready for your tests.